All right. Okay. So erase this. So here's the plan. We're going to take to find grams of carbon. Here's how we do it. We take 3.002 grams of CO2, multiply by 1 mole over 44 grams, because the molar mass of CO2 is 44. So we're canceling grams, and we get. Go ahead, Ben. What'd you say again? Sorry.
0.068.
0.068. Good. Is there any more decimals we could add to keep 3 sig figs?
2.
2 at the end?
Mm-hmm.
Okay. So there's moles of CO2. So now, here's my weird little mole of marker, mole of cap. If I have 1 mole of this marker, I also have 1 mole of caps. Why? If I have 1 mole of this marker, why is there also 1 mole of just this? Because they're connected, right? How many moles of this do I have? 1. Okay? So if I have 1 mole of NaCl, how many moles of Na do I have? 1. How many moles of Cl? 1. Alright, so now let's translate that. Is everybody with me on that? If I have 1 mole of CO2, forget this number. If I have 1 mole of CO2, how many moles of carbon do I have? 1. How many moles of oxygen?
1.
No.
2.
2.
And minus 2.
Okay? So if I have 0.0682 moles of CO2, how many moles of carbon do I have? 0.0682. Right? So the concept I'm trying to make is, I don't care what the formula is, right? If you have just some generic formula, take XY2 or X2Y. If I have 1 mole of this molecule, I have 1 mole of X, 2 moles of Y. If I have 1 mole of this, I have 2 moles of X, 1 mole of Y. If I have half a mole of this, I have half a mole of X and 1 mole of Y. If I have half a mole of this, I have 1 mole of X, half a mole of Y. So what I'm trying to get you to understand is the subscripts will dictate how many moles you have of each part. So if you have 1 carbon, that number of moles will always be equal to the number of moles of the whole thing, because it's a 1-to-1 ratio. But because there's 2 O's, you have to double that number. So if I wanted moles of oxygen, it would be twice that. I don't want moles of oxygen, I want moles of carbon. Everybody following me there? Nicole, you with me? Okay. So that means I have 0.0682 moles of carbon. Alright, we'll leave that alone for a second. Grams of hydrogen. Alright, so we got to take 1.640 grams times 1 mole over. Now, here's the, let's see what I got for this number here. Okay, so what am I dividing by? The molar mass of water, right? So what is it? 18 grams. So, Luke, what'd you get for that?
0.0911.
0.0911?
Yep.
Okay, that's moles of H2O. All right. Liz, you following what I'm saying here with the ratios? And if there's 1 carbon, or 1 carbon in CO2, it's a 1-to-1 ratio. But if there's 2 oxygens, it would be 2-to-1. So, how many moles of hydrogen do we have? Twice that. Very good, because there's 2 H's. That'd be like a marker having 2 caps, right? So if a marker had 2 caps, every 1 marker would have 2 caps, so 1 to 2. So 2 times that number, right? Because there's 2 moles, so times 2 equals 0.1822, or yeah, 0.1822 moles of H. Ms. Snyder, I'm almost there. I'm going to give him another one, then we can talk. Questions? You got to ask them early here.
Is that all you asked for us to do?
Yeah, actually, all I asked you to do was this number right here. Okay, I wanted to see how far you guys could get. I didn't walk around. I didn't talk to you. I want to give you time to try and think on your own. Questions? So now, this is how many moles of carbon are on the product side. This is how many moles of hydrogen. No other compound here. There's no other source of carbon or hydrogen. So this carbon has has this many moles, and then hydrogen that many moles. Now all we have to do is turn this into grams of carbon and grams of hydrogen, and now we know how many grams are in the original compound. All right, so I'm gonna erase this so I have more room. All right, I'm just gonna leave that for a second here. So now grams of carbon, we're gonna do 0.0682 moles of carbon times, now I want grams on top, right? So it's gonna be 12 grams per 1 mole. The molar mass of carbon is 12 grams per mole. The moles cancel, so this will tell me how many grams of carbon I have. To get grams of hydrogen, it's actually pretty easy because hydrogen only has a mass of 1, right? Molar mass of 1. So if you have 0.1822 moles of hydrogen times 1 gram over 1 mole, right? So the molar mass is 1 gram. Some kids start getting confused and they're like, wait, isn't it hydrogen? Isn't it diatomic? So it's 2 grams. That's only if it's hydrogen gas. Hydrogen gas, so that would be if a product was H2. We're not dealing with hydrogen gas. We're dealing with hydrogen atoms in water. So it's hydrogen atoms, that's why it's 1 gram. All right, so that obviously is the same. So 0.1822 grams of H. So somebody do this for me. 12 times 0.0682. What do we get for grams of carbon? Just shout it out when you get it. 14 point.
0.8184. Did I do that wrong?
I'm on the wrong problem. Looking at the wrong problem. Point what? Sorry.
8184.
Yeah, I got 0.819. 0.819 grams of carbon. Okay, we're gonna circle that. We're gonna circle that. All right. Isn't it 0.81? Did I not round that right?
8184.
Oh, all right. Keep the 8 or not. This is just what I had in my notes. So you guys can keep an 8 or 9. It's only off by 1,000. You still should be fine. But you're right. That's not how it would round. So now, in your original compound, okay, let me fix this. You have C, H, and O. So this is 0.819 grams. This is 0.1822 grams. We need to find the grams of oxygen. Then, this is the part where it gets a little confusing. Then, once you get the grams of oxygen, you have to convert that into moles of oxygen. And then you have to use this number and this number, because these are your moles, and divide by the lowest to get the empirical. So you have to go to grams to find oxygen and then go back to use the moles. So find your grams of oxygen. How do you know that? You have the total mass of this. I gave it to you. So just subtract these two and that'll tell you the oxygen. Then you need your moles of carbon, moles of hydrogen, moles of oxygen. Divide by the lowest number, get your empirical. So now it's kind of like those homework problems. So it isn't new, right? Not really. So take a couple minutes, do that. See if you can come up with the empirical formula. And again, feel free to talk.
So the 31 last will count, right? So I had 6.
Well, okay, we're not gonna count them because it's too confusing.
Right, I have 2 that don't have blah, blah, blah. Okay, so these are my numbers. 4, 12, 6, 11, 9.
What the heck?
Yes.
What is that?
Yes.
Serious?
No, those are the numbers that I
Four,
have.
no,
4, 12 for yours.
Yeah.
6, 11.
These are your
I have no
classes.
idea what
This was not me.
Yeah. So,
And I had
Point.
expected all that.
I gotta get some of these, man.
Yeah.
This is brown. I already wrote it down.
oh yeah,
Oh, no, I
over.
Me.
So one.
He did, these 2 count because they didn't sit. 2. And he didn't take it. He didn't sit.
Alright, 0.0262. Oh wait, I'm at 60. My day.
Alright, so you got 20, so you got 1,
No, no.
Anybody get an answer yet?
No, slow down. Relax.
She's so pleasant.
Love it. I think the problem is they start getting more, but then they drop.
I believe that is probably, I don't know. I'll do another grade. Want me to do it?
You guys get an answer?
Yeah.
What'd you get?
C-3-H-A-O.
C what?
H-A-O.
Yep. Very good. Okay, here's another problem. We're gonna do one more, then we're gonna move on. Here we go. So, wait. Did we all get it? Did we all talk to each other?
Ben, did you get it?
Yeah.
All right. Did you guys get it? Yeah,
All right,
you
so
guys
let's,
did.
but I feel like I can't just move on without going over it really quick. So you take 1.367 minus 0.819 minus 0.1822. What'd you guys get for grams of oxygen? I got 0.3645.
0.3664.
Okay, you're right. That's probably because of my rounding here.
Yeah.
So, all right, and then you turn that to moles by dividing by 16.
Yes.
Okay, now remember, it's 16 because it's oxygen atoms, not oxygen gas, so that's good. So then you get, for moles of oxygen, I got 0.0228.
Yeah.
Okay,
We got
all right.
9. Fine.
Everybody on board with me here? And then you
Yep.
divide by the lowest.
Yep.
You gotta stop me if you're not on board. Okay,
I think if I.
all right, now, literally the exact same problem. I'm just gonna read you the new numbers, okay? Your original sample, so this sample here is 23.2 grams. Your CO2 is 52.8 grams, and your H2O is 21.6 grams. Find the empirical formula. The exact same problem. So you take a sample of carbon, hydrogen, oxygen, burn it in excess oxygen. Remember, it has to be excess. All of this is consumed. Here's your original mass. That's your mass of your two products. Find the empirical formula. I'll give you like 5 minutes. So work fast because we got to get going. All right. Okay, so.
You were looking for the Heidi thing, I think.
Yeah, no, I got it. So, which is effective?
It is?
Yeah, but barely.
The record.
Well, no,
not
it's
my
in
phone.
it's in the middle. Here,
Yeah.
we're on. We're being recorded.
I really do.